Good evening, everybody. My name is Iyad Abdalqader. I'm going to discuss a paper made by Dr. John Cabibihan from Qatar University. It was published in 2014. So it's warm and soft artificial hand. And content of this presentation is we'll talk about the problem overview, the objectives, methodology, and resultant discussion, and conclusion and future work. And at the end, I'll finish it with the acknowledgement and your questions. So, starting with the problem. So the problem is many people all over the world, they lose their hands because of war, because of accidents, and there are many other causes. Okay? So losing the hand is not a simple thing. It's just you're losing a lot of communication with other people. And initially, shaking a hand is one of the most important things. It's not just hello there. While shaking a hand, you're just transmitting emotions like love, fear, anger, happiness, and everything. So for those people who lose their communication, and I'm sorry, but this is from reality, okay? They start feeling depression, hopeless, and sometimes they have some suicidal thoughts. So in this, we took the state of the art, which is putting a robotic hand, but it has no feeling. And if you just touch it, you will feel scared. What will happen if I shake hand with this robotic arm? So you usually don't do, and this even harms even more the person. So the objectives is to optimize warmness and softness of the artificial hand, to introduce realistic touch and feeling, okay, for the artificial hand, and to make adaptive temperature skin. Okay? So the methodology, of course, it runs all after the original real state, which is your hand. And then we took several types of materials. Okay? We took four materials that are used in plastic surgeries, which are mostly like there are types of silicone, and we have it has been embedded, an embedded heater and a room temperature sensor. So it feels what's the current temperature, and then it will apply whether it needs the heater or not. Okay. Then the study took place in the softness. So increasing in warmness, and from here we're increasing softness, and sample of 196 people were asked to touch each one and tell which one is more comfortable, to deal with. Of course, after that, a robotic indenter was set to the original hand to check the under one Newton, the displacement under 1 Newton force. So that will give what's the difference between the original hand and the artificial hand that was designed. Later on, it was found that, of course, the sample was taken from 22 up to 37 degrees for the temperature, and the four materials, okay, which were selected, and it was found that material A, which is, as I said, it's a very commonly used sort of silicone. It's called EcoFlex. It was selected by almost 20% of the population that was asked. Then three hands were made. Sorry, not 3 hands, it's 2 hands. This is the original human hand. Now, this is the hand with, if you can see, it has bones inside, artificial bones, and here without artificial bones, just to measure how it will react with the pressure and with the heat. Okay? So we can see here that between the original hand and the artificial hand with bones, it's almost identical everywhere apart from the palm, which has some significance. But here in the one without bones, it was very soft, so it didn't react like it was far from the original hand. And of course that can be shown here in the figure. Of course it was applied to the thumb, index, middle, ring, little, and the palm itself. And as you have seen, that the one with bones, this is for the original hand, this is for the artificial hand with bones, and this one for the artificial hand without bones. And we can see that always the one with bones is better and gives much nearer results to the original hand, apart from the palm, which gave a different value. Later on, so this is the, of course this is the same as this one. It's just to show the areas of the matching. So the artificial hand with bones, it matched the original hand in this shaded area. And this is for the one without bones. You can see the shaded area is much, much less. Okay, so we had here a p-value of larger than 0.05%, which represents that it's matching. 0.05% is if you are less than that, you're not matching anything above that. You're matching your expectation. So then, if you remember the indenter from this test, okay? So what actually happened is, after applying, you can see we have here true positive versus false positive. And that means that according to the touch of the soft hand, okay, of the artificial hand, if you are in this area, that means that you can recognize that it is a true positive, that you're recognizing that this is an artificial hand. And false positive, it means that you cannot recognize. And the one with bones was not recognized, while the one without bones was not recognized. Here for the sample, we can see that cold and warm, they are much near the human with the warm feel. People couldn't recognize that this is a true hand. You can see very certain to be human hand, 51 to 45, while 19 only for the cold hand. So we could conclude that the future of the artificial hands is to be soft and warm, and to give the original feel, the feel of the original hand. And for the future work is something that I am working on, is to make an automotive soft and warm hand. Okay? And I want to thank everybody here, Mr. Arshad and Dr. Simon, and Dr. John, the original presenter of this paper. Thanks a lot.